Alright, hello guys, hello. Hello guys. Today I'm going to teach you guys how to get a feel for C++. And before I say anything else, the book we're going to be using today, if it loads, says open it again. Alright, the book we're going to be using today is starting out with C++ from control structures to objects, the 8th edition, but if you're an edition off, you find a PDF for the 7th or 9th edition, you should be fine. I think I might as well include the PDF in the GitHub anyways, but I'm going to teach you guys some stuff, how to get you guys started, and then I'll go over chapter 2. You really don't need to know about chapter 1. It's just talking about what computers are and what they can do. If you clicked on this video because you want to know about C++. So before you even think about programming in C++, the first thing you want to have are your tools. Like you got any project, any experiment, you gotta have the tools for it. And so there are many ways to go about programming in C++, but for a beginner, some of those are very, very wrong, and they can cause more trouble than they're worth, and occupy more computer space than they're worth for that matter. So there are like 2 or 3 recommendations I make. Yes, three. All right. So we're gonna do the first one. The easiest one is to use this cpp.sh. It's basically like your and it's an online IDE, and an IDE stands for Integrated Development Environment. The only thing it can't do is the main problem with it is that you can't use more than one file at a time. So that you can't use one source file at a time. You gotta write everything in here. I mean, not 12 lines, don't worry, you can add more, but that doesn't matter for a beginner, it doesn't matter. In fact, throughout this entire book, there's only like 2 chapters that you might want to take use more than one file and separate your program into different source files. You don't need to worry about that. In fact, there's no, for your first C++ class, you won't be doing anything like object-oriented programming anyways. So this is a non-issue. All your programs will be relatively simple. However, if you want something more advanced and convenient that actually saves your work, because like this doesn't save your work, you'd have to copy paste this into like a text editor like Notepad and copy paste it back in. The next one I would recommend is repl.it, repl.it. Now I've got one. I mean, I don't want to sign. You can. It's free. You can sign up, but I want to show you the stuff I've made for it within it. More so what it looks like, if anything. And the interface has changed. That's great. Alright, but all you have to do when you want to like make a new C++ program and get it to run and stuff, you just go to new repel, you choose the language. You probably want to go with C++11 and just create a repel. You'll wait for it to work. And basically what this does is that it's kind of giving you the GCC compiler, and the ability to save files on the cloud and all that without needing to install a program. Everything is done on the cloud here. So it's kind of like Google Drive but for your code. So we got a hello world program. We can just run it right here, and I can name this whatever, demonstration for video. Saves that. It's been a little slow today, it seems. Make a small modification to this. And run it. And even if we leave here and we go back to it, it will still be there. So my repels, what the heck? Oh, maybe it's example for video. Why didn't it save it? Okay, maybe don't close too quickly. Let's do that again. Sometimes it's buggy. So okay. Now, instead of closing the tab, let's press home. Let's see what happens. Okay, here it is. Here it is. 1 minute ago. And if we close the video, we sign in again, it'll be there. Very strange that I got deleted on the first time. Okay. Even after we close the tab, it's saved in the cloud. We don't have to worry about anything. Okay. Now, the slow part is over. I'm just going to go directly to what I use, which is using whatever text editor I have. There's a million of these. It's best that if this is of course a Linux only solution. There's probably something similar to this on Windows, but if you're on Windows, I suggest you just use repel.it because downloading an IDE such as Visual Studio just takes up too much space, especially for the programs they're going to be writing, and you'll get a bunch of weird errors through mistakes you didn't know about that have nothing to do with the program you're writing. It's more so that you put the file in the wrong folder and Visual Studio doesn't like that. Just don't bother. And don't bother with Visual Studio, don't bother with code blocks until you're very comfortable with this beginner stuff, so you're absolutely sure that whatever errors you're getting when you read it, you know that it's not it's either actually the code you wrote, or it's the fault of the IDE. What I use is a text editor and the terminal. And how this works is that we'll actually get into that, because whatever, I need to teach you guys anyways. So chapter 2 is basically telling you the very basic essentials you need to know for writing any program. You gotta know this stuff. It tells you how to do a hello world. It tells you how to add numbers. And you know, since we're here, let's do an example. So I'll walk you through what this stuff means. Include IO stream. This is the library. This is the library of a programming language. Is like the vocabulary the programming language understands. Most of it, anyways. I mean, not most, but it is a section of it's a section of the programming language's vocabulary. If you want the program to have a programming language to use more commands, or to be familiar with more commands when you're putting them in, then you're going to be using other libraries other than IOStream. You're going to be, there's others like IOmanip, string, vector, and you'll learn about those along the way. So the second line is namespace std. This is just so that it's more like the, I guess you could say, grammar. It's like, yeah, it's a different way of writing some of the same commands, and it simplifies things, makes the code a lot more readable. Oh, by the way, IOStream, that stands for input-output stream. You put stuff in, you get stuff out, and that's all there is to it. That's usually what it concerns. Int main. Every C++ program is gonna have a function, the main function in particular. Now, some classes, for remember, would teach you to start with a void main, but you know, I think some compilers don't like that. Or sometimes when I did it, the programming environment I was working with said, "Hey, what the heck is this?" So just always do int main, and don't think about void main. You want to have as little sources of error as possible. So this guy isn't doing hello world. He's saying programming is great fun. And return 0. That is telling the program to end the program, that there's nothing left to be done. It returns the value of 0 to main. Int stands for integer. Functions in general will start with a I guess you could say something like prefix, such as, so we've talked about like void main. Void was where you'd have nothing returning. Though in the case of int main, this program will still work even if you don't put return 0, but better safe than sorry. Put it in anyways. And if I haven't already mentioned, programming is great fun. We'll show this sentence to the screen. Cout means output this thing into this onto your screen. So let's save this. We're going to save it as example program.cpp. And yeah, when you save your files in a text editor, you're like doing what I'm doing. Make sure to put the file extension as .cpp, otherwise the compiler will not understand. Now before we can run this, you want to check that you got GCC installed, so, or in this case as part of it, G++, and it says G++ is already newest version, G++ that's manually installed, and now we're ready for sure to put this in. Go to the directory that you're working from. So this file is saved in documents CPP conquest, and the rest of it is the file name. So CD stands for change directory. Now we do G++ example program .cpp -o, that's the output, what you want to call the executable. And if you don't know, when you run a program through a compiler, it's gonna give you a binary. In Windows, the binaries will end the file names with exe. Here, it doesn't matter. You can put the file name, extension, anything. So I think even if I put, let's say, joke.exe, it'll run it. Let's try. Yeah, it worked. Cool. The file extension doesn't matter for us in Linux when it comes to what we call the binary output. Now, as you can see here, it did not make make a new line. It just continued to dude guy at Ryzen. And why is that? Because when we do cout, it doesn't automatically go to the next line. You have to either do /n. We'll save this, recompile, rerun, and now you can see that it goes to the next line because we put the /n. Or if that's a little, makes things a little harder for you to read, you can also do end line, and it'll make it more clear. You separate it. Save the file again, recompile. Programming is great fun, and you can add as many of these as you want. Boom, look at all that space we created. Okay, so let's move to the next example program. This guy is showing what it would look like on Windows for a different program. Like when you output it, you'll get the command prompt, command line. So this guy is showing that you can separate your strings however you want, and it won't matter what the output is. The next line will always be, it'll always go to the next line when you put your /n's or your ENDL end line. More examples. This guy goes over what that include IO stream means in greater detail, so read that if you want the proper terminology for it, proper explanation. Okay, here's the first example with variables. So we're gonna make a new new program. We're gonna go along with this. Okay. Example with integer.cpp. Alright, so this program, everything else that we talked about, int main using namespace std, all that's the same. We are now introduced with our first variable, a number, integer number. Int stands for integer, and it declares well, an integer. If you know your mathematics or basic mathematics, an integer is any number with no decimal points. So like -5, 7, 2, 434, whatever. It can't have any decimals. If you give it a decimal, it's not going to understand what you're, it's not going to show that decimal. And here we're telling it that number is going to equal number 5. And that this cout, when we want to show the variables, we're going to show it to the console. We put our string of text, and that says the value in number is, put a bit of space for readability, number, and then we go to the next line. So let's compile this. Example program. Oh shoot. Okay, example with integer.cpp-o, and let's call this haha dot who cares. And you see the value in number is 5. We did not write the number 5 here. It already knows what and because it's not, a string, it's actually the variable name. And we don't even need to call this number. We can call this anything you want. Remember, a variable can be called anything. Just be consistent, so that when you call it something, so like let's see if we called this cringe, it's not going to understand anymore what you meant. It's going to give us an error. Number was not declared in the scope. Another thing I'd like to point out is that you don't have to separately declare a variable and then in the next line say what it's going to equal. You can say integer cringe equals 22, and then we'll put cringe right here, save it, recompile, and the value in number is 22. Of course, I should have changed that as well, but the value in cringe is 22. Alright, so that's variables for you, integers at least. Sometimes a number isn't a number. Alright, so here it's just talking about that if you put it in quotes, it's not going to be a number anymore. It's going to call it a string literal, which, go read this. Strings are intended for humans to read, not for machines to read. Unless, of course, you're using it as cout. So here we have apples equals 20. It's just mixing it in. Identifiers. This is so there's a bunch of words that you can't use for variables because they mean important stuff. Bool means is like a true or false. You can say bool equals true or bool equals 1 if you also want to call it true, or you can call it bool equals 0 or bool equals false for false. Like these terms, these are used in object-oriented programming, private, protected, public. Go to is when you want to go to a specific line, but you have to put the label with it. You can't use you can't go to a line number. Like right here, I wouldn't be able to use go to and says okay, go to 6. That's not going to understand. You have to say you have to label it. If it comes up, we'll talk about it later. If I read through this whole book and realize it doesn't talk about go to, then I'll show you some examples where that's used. A bunch of stuff here. This is how you're going to name your variables. Do not put numbers in front of a variable. You can use them in a variable, but you can't, like at the end, but you can't use them in the front. And you cannot use weird characters like number signs or smiley faces even if it's a Unicode smiley face, you know, it's not like a emoji or anything like that, you still can't use them. So I think if I was to do, I don't know if it's supported in this text editor, if I was to do cringe alt 10, oh, it doesn't even let me. Alright, let me show you what I'm talking about. So if I do, wait a minute, wait, let me try again. Alt 10. Alright. If I have my num lock off and I've got a numpad and I do Alt 10, alright, well, I guess that's a Windows only thing or something. I remember I was able to do that in Windows. Let's keep going on. Alright, so there's a million different types of versions of integer. When you want to use less memory, less RAM, you can opt for a smaller type, especially if you know that you're not going to go beyond a certain range. Short int means an integer that can hold the value between negative 32,000 and 32,767. So negative 32,768 to 32,767. Our regular integers is between a negative 2 billion whatever and a 2 billion positive 2 billion whatever. These numbers are not random or arbitrary. These numbers are picked because that's how memory is arranged. I think so what, 2 bytes, that's 16 bits. The conversion for this is that 1 byte equals 8 bits and 2 byte, so more bytes, more bits. Just take the number here, multiply it by 8, and if you wanna get an idea, there's like these decimal to binary, or in our case binary to decimal. Let me show you a 16-bit number. The highest possible 16-bit number is 111, 16 ones, okay? Oh, I didn't like that. Don't do spaces in this converter. Alright, wait. Yes, that's correct. That's right. 65,535. That's the biggest number you can do with a 16-bit binary number. And over here, it's between, you see, oh wait, that's not 65,000. Actually, it is. It's just that they allocated half the numbers to be for the negative sign and half the numbers for the positive. If you're not going to be using numbers, as you can see here, unsigned means, you know, no negatives. And you go from 0 to 65,535. So this is a 16-bit number. Integers by default are 32-bit. So 32 ones is this number, 4,294,000 whatever, unless it's signed. And then there's like there's a different way to go about it. The leading digit indicates if it's a negative or positive. You can read about that later. Alright. So here's a more complicated, I guess you can say. So we get rid of this. Oh, new file. Sure. Alright, I'm gonna do some modification. I should have read more carefully. Negative 24,276. Why the heck did he put long? Wait. Oh yeah. But still, he didn't even need to use long. That's weird. Well, I guess he's just demonstrating. Long in this since I'm going to assume it's a long integer. Sure, we'll just keep the rest. Alright, and if I didn't mention it, I think removing the return 0 is inconsequential, but put it in anyways so your teacher doesn't complain. More. Oh, cool. This guy's gonna start talking about never mind, not yet. You better get to it though. Alright, characters. This it's literally that. It's just a character. It's 2 bytes, and you can hold one character with it. Whether it's an A, whether it's a B, whether it's a X, you know, go wild. But you can't hold more than one character. Ooh, and keep in mind, characters can have, there's a difference between lowercase and uppercase. In fact, when it comes to your variable names, remember that things are case sensitive. And that's later on, if I get to it, these have separate values. Like the uppercase A and lowercase A will have different values from each other. Uppercase B, lowercase b have different values from each other. And wait. Oh, yeah, okay. That's funny. Forgot to add that last line. Alright, cool. And what do you know? They actually talked about it. So, let's make characters the sequel. If you assign a number to a character, it will show you the letter instead of the number you gave it. Because reasons. Because it's a character. That's a feature that its data type has. That can be very useful. Yeah, let's call it numbers in disguise. All right. ASCII character chart. I think the book has it, but I'm not gonna look for it. That's not cool. Too complicated looking. One of these is bound to open. Give me a second. How the heck is it not opening? Alright. So, the characters you were most familiar with, like, you know, the alphabet, is gonna be around here. And here's the associated decimal values. Here's the associated here's the associated binary values, hex, and what they correspond to in ASCII. So if I want to do lowercase a and lowercase b instead of capital A and capital B, I would do 97 and 98. And I'll recompile this. And boom, lowercase letters. So keep that in mind. Let's go back. The string class. So in case you thought putting one letter at a time is lame, and you want to put entire strings of text as a variable, so like you want to have a variable that says your name or a movie title like this guy's doing, then that's what strings are for. So you don't have to have like 20 different variables just to write your name down. Convenience. Yeah. Why the heck is this? I don't know why this guy calls it a class, and when we don't even know what classes are yet. I should have kept it as library. This is the string library, not class, especially when you're including it like this. I mean, maybe he's technically right and it used to be a class, but if you're including it with these brackets, that means it's official. It's not some fan-made mod or whatever. So, oh shoot, I didn't want to do that. So my favorite movie in this case, or one of my favorites, I got lots of favorites, would be RoboCop. And if I was to run that, there we go. My very favorite movie is RoboCop. So you can, or you know, how about Hot Fuzz? Oops. Yeah, Hot Fuzz. If I was to do that, you know, it works. Floating points. These are for your decimals. And just so I don't make a fool of myself, I want to check something by scanning the rest of this chapter. Alright, so as far as I know, this chapter does not tell you about what's called precision. How many decimal points do you want for your... How many decimal points do you want in your output when you're doing a cout? You're printing it to the terminal. So that's lame. This, you see this E plus 011, you think that's readable? You think we would want that, especially as a beginner? Most noobs probably don't even know what scientific notation is. Of course, that's assuming they didn't take a science class in high school, but like, you know, if I want to teach this to a middle school, they're not going to be as familiar with scientific notation as a high school or college student is going to know. You gotta keep it, gotta keep things simple, especially for a first chapter. Cause yeah, it's chapter 2, but come on now. So I'm gonna teach you something this guy's not gonna teach you. Not yet. He might teach it later. And that's gonna be IO manip. That's another library. And it lets you mess around with how long do you want your decimals, or how you want your decimals to look. Like, what if you want all the decimals? But like, you don't want the E in there. So, by the way, floats, this is a number, that's the type of variable with the decimal. There's another one called double, and that's cool too. This guy's making use of both of them. Double, I think, is bigger. That's the 64-bit variant. So 49597 E11. Mass equals 1.98930. All right. Instead of showing this gibberish, I'm gonna pull a switcheroo. Sun is. We're going to do set precision, and we're going to tell it how many decimals we want. For now, I'll put 2. We're going to want 2 decimals. And we don't need fixed because we got more decimals. But more, I mean, like, I'll talk about that later. Like for the second line. So this one's going to show 2 decimals. And what the heck did this guy do? Why did he put a slash there? A typo, I guess. The sun's mass. Yeah, maybe there was a reason for that. I'll test it. Maybe he doesn't like apostrophes or something. Whatever. Alright, here we're going to do set precision like 20. And we're going to do fixed. So even if there is more decimals than this. Well, how about 40? Yeah, let's do 40. That'll make sure that we get like guaranteed for. Like, let's say there's this only goes to however much. Then it will show all 40 zeros. What did I do? Oh yeah, I forgot to put the actual variables in. Alright. So here we have two decimal, or like one decimal point, and it put the rest in just the e's. If I increase this, that would change. But here like it's showing a whole number. It's not putting any because we put like 40 decimals. We force it to say 40 decimals. If I increase this, this will not be just 1.5. This will be like this will be more. Let's try 10. Let's try 10. Recompile. And it's like it shows more than this guy is showing. So that's floats. So you remember to use your set precision and your fixed. Fixed is when you force it to show more. And set precision is like so you see all these extra zeros. If I was to put if I didn't put the fixed, it wouldn't show these extra zeros. So if I remove this, it only goes to 6 because it says, well, there's no point zeros of it, and there's nothing other than zeros up back there, so I'm not going to show it. Bool is true and false. That's all there is to say to it. If you want to print it, it shows 1, it shows 0. If it's true, it's 1, if it's false, it's 0. I don't care about that. This is when you want to show the size of a variable. That's cool. Don't do this get into the habit of knowing variables you're working with. Maybe if you're a pro hacker or something, use this. This automates the data types, where it knows that if I do a D, then this is going to be a character. But for the sake of demonstration, let me make one. Auto cool. I don't know. And I'll put F. Oh yeah, that's gonna be your grade after you use this, and I'm your professor. And I'm gonna and if I was to do C out grade, and then I did grade equals 2. Well, that's not gonna show up as anything. Let's do 60. And I did it again. It'll treat it as a character constant. Oh, well, it gave us this error. I don't. 80? Alright, cool. You get the idea. Alright. This is telling you don't put a variable you haven't declared yet before it's been declared. Like, if you want to show the value, don't put the variable here. Put it at the top. Put it before you're going to use it. The compiler reads stuff sequentially unless you tell it not to, or there's like by default assume sequentially for all our intents and purposes. Especially in this chapter, everything goes from top to bottom. So let's show you what happens. Oh, right. Okay, that's the error we see. We see value was not declared in the scope. But what you told me was not declared is right here. Well, dummy, you didn't put it in the right order, so it's thinking it doesn't exist. Now we put it, it's going to say it exists. I mean, oh, wrong executable. I don't even... Here it shows 2. Okay. Cool. And remember your order of operations. I'm not even going to tell you that abbreviation. If you don't know your order of operations, that parentheses go first and the rest goes wherever, then don't talk to me. Oh, exponents do not exist here. You got to add that yourself. Or add a library that supports exponents. It only supports the basic 4. Addition, subtraction, multiplication, and division. This is also technically division, except it just gives you the remainder of it. So if I do 7 modulus 3, it's gonna give me a 1. And if you don't believe me, watch this. Might as well use this again. Value mod 3. What? Oh yeah. Right. Modulus. Oh. Okay, give me a 1. If I didn't say that, then there's something wrong with me. So this is just showing how you can combine, like when you were declaring variables, you can like do calculations right there. Like you say, okay, this variable equals this variable times that other variable. And like I had done with over here where I put the variable and the operator in the same line, you can do that with your variables. No pressure. Comments. These are all comments. This code will run exactly the same no matter how many comments I put. The compiler does not read it. This program was written by who was it really written by? It was written by the guy that died in New York. Under extremely unusual circumstances that totally did not involve any federal agents. Alright. And it runs the same way. If I was to copy this, or like, this is one giant line. If I maximize this, don't do that. There's another way of writing comments if you want to have it span a billion lines. Actually, I'm not even going to copy that comment. Help find me 3 ice cream cones. Guess what? What the heck? That's also a comment. And you know, when you got your syntax highlighting on your text editor because you have the program saved or whatever, like it's saved as a .cpp before you started writing it, then it's gonna tell you that okay, this orange stuff is a comment. And if you just leave that loose, it's gonna say, what the heck? This is also, everything is a comment. What happened here? So don't do that. It's gonna run the same. Boom. Alright, let's see what this guy's talking about, those multi-line comments or whatever. Named constants. What? Constants is when you want to keep a value from changing. Like you don't want it to be renamed or anything. If I would const like if I did, let's see, const int value 7 and I say value equals 8, it's gonna call me a serial maniac. Don't do that. See, assignment of read-only variable value. So you can't change this. Constant stay constant. There's usefulness to this, but it's not very apparent right now for the average programmer who starts here. And that's it. That's the whole lecture on chapter 2 Gaddis C++. There's like a bunch of programming challenges here. I'll put the GitHub in the description in case you want to look up the answers for all of these. I did not answer any of these questions. I'm just thinking about the what's it called? The actual programming. These are just, okay, fix the error here, or convert the pseudocode to C++ code. That's a waste of time. Who cares? Well, I don't do multiple choice assignments. If I was a professor, I want to do multiple choice as much as I could. I'd say, just give me a bunch of programs on a piece of paper, not a piece of paper, on your computer. Only work in a virtual machine of Windows 98 or whatever, so you don't have access to the internet or access to a modern web browser, and just follow the instructions. Solve the problems that you're giving you. There's no point in restricting someone to these questions. Vocabulary and all that is nice, but you learn programming by programming, not answering these types of questions. So I only did the programming challenges. Anyways, that'll be it. Thank you for watching this long video made by me, Sharoy Viducci. Hope you guys have a great day, evening, night, iftar, or whatever. And yeah, peace out, homies.